If you have a Huion drawing tablet, one that uses the PW517 pen, and if you ever need to buy another PW517 pen, I'd like you to pause and instead consider buying a pen from the PW550 series. I think pens in the PW550 series represent a compelling choice over the PW517, and that's what I'm going to explore in this video. Let's start with the basic question of backwards compatibility. Huion specifically says that the PW550 pen is backwards compatible with those tablets that use the PW517 pen. And they say the same thing about the PW550S pen. And to be even more explicit, Huion provides a list of tablets that are compatible with the PW550 series. In terms of cost, the PW550 pen costs the same as the PW517 pen, although the PW550S costs $10 more. In terms of look and feel, if you are used to using the PW517 pen, and then if you start using the PW550 pen, you won't have any problems adjusting to it. It has the same basic shape and weight. The only difference that you might notice is that the buttons of the PW550 series pens are a little more crisp and clickier than the PW517. And in my opinion, pressing them feels better. Now, what about the nibs? My PW550 pen came with the felt nib, which is what you see here at the top. And my PW517 pens have always come with a plastic nib, what you see at the bottom. In this photo, the nibs look the same, just made out of a different material, but actually, you should be aware that these two pens do not use the same nibs. The real improvement that the PW550 series pens bring are how they handle pressure. So, to talk about that, I need to give a little background on the topic of pressure handling. How a pen maps physical pressure to logical pressure is called its pressure response. This is a pressure response chart. The x-axis is the physical pressure in units like gram force. The y-axis is the logical pressure. That's basically a number from 0% to 100%. If you take a series of measurements of an EMR pen and plot them on this chart, you'll get a blue line with this shape. It curves over like this, and that is very typical for every EMR pen I've ever tested. There are some values on the x-axis we should pay attention to. On the left, it begins at 0 gram force, which of course means no physical pressure. Moving over to the right just a little bit, where the blue curve starts at the bottom, at that position is the initial activation force. And then if you trace the blue line all the way to the top where it stops, that position on the x-axis will be the maximum physical pressure of the pen. And finally, the pressure range is defined as the difference between the maximum physical pressure and the initial activation force. Because the initial activation force is really small, we can see that the maximum physical pressure and the pressure range are almost the same value. For an EMR pen, we want a high maximum pressure. In other words, this gives us a wide pressure range. And very soon I'll clarify exactly why that is good. But just to put a clear number to it right now, after looking at over 50 EMR pens, I think that if your pen has a maximum pressure of 400 gram force, it has a good maximum pressure and thus a good pressure range. What would happen if we had a pen that had a low maximum physical pressure? So instead of 400 gram force, imagine it has a maximum physical pressure of 150 gram force. Well, in those situations, even if you are trying to draw with low pressure, you can accidentally bump up against the maximum physical pressure very easily. And for example, that might produce a stroke like this, where it's starting thin, but suddenly it just bumps up to the maximum width. And that's because with a low maximum physical pressure, it's really hard to avoid hitting it. The shape of the pressure response is also interesting. In particular, notice that the blue curve is very steep at the bottom left. This means that for low physical pressure, the pen is really hypersensitive. Small changes in physical pressure at the low end produce big changes in logical pressure. If you compare the pressure response of two pens, one that has high maximum physical pressure and one that has a lower maximum physical pressure, you will see that the pen with the lower maximum physical pressure has a pressure response which is much steeper at the low end. And this means it will be much more sensitive to small pressure changes And that means it will be much harder to control how pressure affects your stroke. And this phenomenon can really impact the quality of your stroke when you're drawing at low pressure. For example, I'm drawing here with Clip Studio Paint using a 100 pixel brush, and I'm drawing at relatively low pressure. And I'm trying to keep the pressure consistent. At the top, this is what normally happens. The stroke width really varies quite a bit. And again, this is because the pen is hypersensitive at low physical pressure. But on the bottom, I will use a pressure curve so that the pen is less sensitive at lower physical pressure, and now the stroke looks more controlled and more even. It looks much better. Later in the video, I'll talk more about the kind of pressure curve that will help you achieve this effect. The thing to understand is, these curves work best if you have a high maximum pressure, or in other words, a wide pressure range. Before we talk about the Huion pens, I want to give you a good sense of what a really good pressure response looks like, one with high maximum pressure. I'll do that by taking a look at the Wacom Pro Pen 2, model number KP504E. I'm going to use this blank chart to plot the pressure response data. Those two gray dotted lines are the upper and lower bounds of the measurements I found looking across over 50 EMR pens. So every pen I'm showing you will fit within those boundaries. Now let's take a look at the Wacom Pro Pen 2. I tested 5 different units. Now in any of the graphs I'm going to show you, the initial activation force should be at the bottom left, but don't take the graph too literally there, because I'm not really that good at measuring initial activation force, so don't form any judgments about the IAF from any of the graphs I show you. Just take away one fact: the initial activation forces are all relatively low. The next thing I want to draw your attention to is the way the curves are bent. Again, this bending of the curve is very typical for EMR pens, and it means that the pens are in general hypersensitive to the lower end of physical pressure. I found this to be the case in every EMR pen I tested. And now, taking a look at the curves and how they end in the upper right hand of the chart, you can see that their maximum pressure is pretty good. Actually, it's in the excellent category. All of them but one end with a maximum pressure of at least 700 gram force, and the other one is something like 695 gram force. The Wacom Pro Pen 2 has the best pressure range and maximum pressure in the industry. Now let's take a look at the PW550 series versus the PW517. Here are the pressure response charts for 5 units of the Huion PW517 pen. And just take a moment and think about what you notice here based on what I've told you. And just remember, just ignore the initial activation force. What we can observe is that the maximum pressure of these PW517 pens seems to be quite variable. Some of them have a maximum pressure of less than 200 gram force, which is not great. One of them has a really good maximum pressure of about 450 gram force. And of course, like every other EMR pen I tested, they are hypersensitive at low physical pressure. Now let's take a look at the PW550 series. The differences should be very clear. The maximum pressure tends to be very good, over 500 gram force for 3 of the 4 pens I tested, and one of them is just in the OK category. That specific pen is, I think, an outlier. Maybe it's kind of defective because it's so different from the other ones. So doing a comparison with the PW517 pens in blue and the PW550 pens in red, you can see that the pressure responses overlap a little bit, but in general they are quite different. The PW550 pens tend to have a significantly better maximum pressure. Now I want to be clear about what I'm saying. I am not telling you that every PW550 pen is better than every PW517 pen. As we've seen from my data, there is some overlap. But based on my measurements, I see that the PW550 series pens tend to be much better in terms of their maximum physical pressure. I've spent a lot of time talking about maximum pressure, but now we need to talk about initial activation force, IAF. To summarize, I think the initial activation force seems about the same between the PW550 series and the PW517. In my subjective use of the pens, and I have used both extensively, I just can't really detect a difference. But what about my objective experience? Which means, what did my measurements reveal? Unfortunately, I have no answer for you. As I've said in many videos, I am just not good at measuring the initial activation force with my equipment. When I try to measure the initial activation force, there's just too much noise. My measurements can vary by plus or minus 2 gram force. And so I'm not reliably getting the same results as I measure. And this is true for all the pens I have, not just for the ones I'm talking about in this video. When I look through the community and I search online, I see people talk about these two pens, and it seems like people have different experiences. Some people don't notice any difference at all in the initial activation force. Some say the PW550 series has a lower IAF, and some people say the PW550 series has a higher IAF. And we have to keep in mind that the pressure response and the initial activation force varies by pen even of the same model. So it's hard to pin down a strong statement about comparing the initial activation force, but ultimately, my conclusion would be that there is no consistent difference between these two series of pens in terms of initial activation force. If you do need to replace your PW517 pen because you lost it or broke it, or perhaps you want to get a backup pen, then instead consider getting a PW550 pen. Because I think the odds are you'll get a better experience, and at the very least, it shouldn't be any worse. Earlier I said to get better strokes with these high maximum pressure pens, you need to take advantage of pressure curves. So I wanted to talk about that in a little more detail. And the problem here has to deal with how we handle the steepness at the lower left part of the pressure response. What a pressure curve can do is take that pressure response and modify it and flatten it out a bit. This makes it not quite as steep, and this will improve your strokes. The pressure curve in your driver probably looks like this, a straight line that goes from the bottom left to the upper right. What I'd like you to do is that if you have one of these pens with high maximum pressure, is to bend that curve down a little bit as shown here, because it'll give you a better behavior at lower physical pressure. And remember, this works best if you have a pen with high maximum pressure. Using a curve like this with a pen with lower maximum pressure tends not to really help at all. And here you can see what the effect of such a curve should look like. There's no single curve shape that's going to work for everyone, so play around a bit, experiment, and find what works for you. Thanks for your time, and I hope you enjoyed this video.